Good afternoon, folks. Welcome back. You've all made it through. We've survived. The exam was hopefully, hopefully somewhat fun. Maybe a little frustrating, hopefully a little bit. Not too bad. Any feedback or comments or questions about it? It was good, says Gabriella. Great. That's good to hear. Was it bad for anyone? All exams, I guess, should be bad for some people, but hopefully not too bad. Our goal here is not to punish you. It's to just, test your knowledge. Like the format. Thank you. This is a format I've been working on uh, for about a year and a half. I've been trying to get exams to go. Before the pandemic, we had to do everything on paper, which was just kind of crazy. So this is an opportunity for us to do actually computer-based exams, which is a nice thing.
I also will add to that. I like the computer-based exams, specifically the GitHub part where we could upload and like produce our own code and things like that, because I feel like that really tests us compared to like exams. But that's just my personal opinion.
Yeah, one of the criticisms of a computer-based exam, of course, is that students have an easier time cheating. I'm not sure it was so hard to cheat before. I'm not convinced, but definitely you know, there are ways you can structure an exam that makes cheating not so helpful in some ways. So I've tried to do that a little bit. I've tried to find ways that if you do cheat on the code, for example, we'll catch you. Pretty much, there's no problem catching people who have the same code. And yes, you can cheat, of course, on the multiple choice quiz stuff. Hopefully, not too many people do that. So I mean, cheating is always a problem, really, in any exam format. The only solution to, I think, online exam cheating is to have a service where they basically take over your computer. You basically install software that prevents anything that you do from going unnoticed. So if you were to, type, we notice it. If you change programs on your computer, it's logged. So there's sort of spyware software that actually looks at every little thing you do, and the university at this point has been reluctant to do that, but that would be really the ultimate solution for preventing that, which I don't think we need to do. All right, so let me kick into our new material. Let me share my screen and get started. All right, so our goal today is to discuss MongoDB. That is a different kind of a database that you're not necessarily familiar with. So we're going to be jumping into it. We're going to cover setting it up so you all can get access to MongoDB. And we'll discuss what it is, of course. And we'll then look at some CRUD, creating, reading, updating, and deleting records. But anything else you guys wanted to bring up before we jump into this? Doesn't have to be exam related. All right. So the setup. I've got this slide deck that has some outline of how you're going to set up your MongoDB. So let's just run through some of this. MongoDB, just to begin with, is a document-oriented database. That is, instead of relational database. Remember, we called SQLite a relational database. This is not a relational database. It's a document-oriented database, which is a different kind of a thing, which we'll see a bit about as we go through it. Records are not stored as row-column type structures. Your tables are not rows and columns like they are in CSVs and in spreadsheets and in SQLite or any relational database. They are stored as JavaScript object notation documents, which we've seen some JSON plain text data format before. That's the way records are stored in MongoDB. So if you have a CSV, the easiest database to import a CSV into would be a relational database because the data is structured much the same way in rows and columns. And if you have a JavaScript object notation file, well, the easiest database to import it into would be MongoDB because that's how it stores its data. Commands and queries are issued into a client program, and those commands and queries are not in their own obscure language like SQL. They're in JavaScript, a very common language. MongoDB can be integrated into all the programming languages you know and love: Python, Ruby, Java, JavaScript, of course, C, C#, Objective-C, pretty much whatever programming language you might like. You've got a way to run MongoDB commands from that programming environment. That's like SQLite, so you can say the same thing about SQLite. They're both easy to integrate into other programming languages. So it's not a relational database. It doesn't use SQL. It doesn't have data in rows and columns. It has a document-centric organization. And the goal of MongoDB is to be able to scale up and out rapidly. What that means is if you have more and more users of your application that is using MongoDB, it has no problem allowing for more and more simultaneous connections. So you have maybe an app that taps into a MongoDB database, and you might have 10 million users of your app every day. You might have at any 1 second several million even, or several 100,000 users all tapping into the database at the same time. And MongoDB makes it easy for you to allow that number of simultaneous connections. SQLite is not meant to be like handling massive numbers of connections. It is a good relational database, but it's more for single user or small number of user type applications. If you wanted a relational database that could handle a lot of simultaneous connections, you would go with a more kind of a bigger piece of software. SQLite is very small and very proud of being very small. A bigger relational database would be like Oracle, would be Microsoft's SQL Server. MySQL is another open source big relational database system. So SQLite is a nice, compact, small, portable relational database, but is not great for this app environment where thousands or tens of thousands or millions of people are all getting into the database at the same time. Anyway, MongoDB is one of these big database systems. Yes, it's not a SQL system, but it's nevertheless one of these enterprise level, you need a special computer for it kind of database systems. So you don't have tables, rows, or columns in this document-centric, non-relational database system. Documents are what you used to call a row, is now called a document. And instead of a table, you've got a collection. So a collection is a collection of documents. The same way that a table in SQL was a collection of records, documents are in collections. So they've kind of just renamed the terms a little bit. A database can have many collections, the same way that a relational database can have many tables. So it does follow a similar way of organizational principles, but we do use different terminology of documents instead of records or rows, and collections instead of tables. I see, Anthony, I see your comment in the chat. Sorry, I didn't see it earlier. So in a practical setting, if wanted to create a web app, should they go with NoSQL or SQL type database? And Gautam says, I guess it depends on the needs of the web app. I would agree. So you don't pick just based on one, you don't pick a certain database based on one feature. You look holistically at what you're trying to do and try and find the database that matches the best. If you're trying to make a web app that is going to explode and you're going to be Mark Zuckerberg too, then yeah, you'd go with something besides SQLite. SQLite, given the keyword light in there, is not meant to be a huge, massive, thousands, hundreds of thousands, millions of simultaneous connections kind of a database, as I mentioned. You could nevertheless find a very good relational database system that can handle that number of traffic. Like I said, Oracle, Microsoft SQL Server, MySQL can even do it. Facebook ran on MySQL for a long time until they had to grow into something bigger. So any relational database on the industrial scale level, which is pretty much all of them except for SQLite, would work just fine for a certain number of connections, a large number of connections in a web app. A web app would, often people who develop web apps know JavaScript very well. You can't really work in the web and not know JavaScript. I mean, you can write HTML code, but you and 10 million other people are all trying to get the same job writing HTML code. So it's not a reasonable skill that differentiates a person from other people in the web development field. JavaScript programming is something that differentiates people. So if you really wanted to go into web development, learning JavaScript properly would be a valuable thing. So the skilled web developers already know JavaScript from making web pages that use it. Having MongoDB use JavaScript as its native language would make it a very attractive database system for a web app developer. Not to say that its features and so on are so great for web apps. They're fine, but so are relational systems. It's really just that it's familiar, so that it's using a language already familiar to the developers who might be approaching it. Whereas learning SQL for a web developer is like learning a foreign language that is from a completely different language group. So, for example, if you speak a Latin-based language or a German-based language, learning some sort of Slavic language, for example, might be significantly challenging because they're from a different language group with different grammar and so on. So that's what learning SQL is like for any other kind of programmer. So anyway, those are some considerations. JavaScript, great. MongoDB uses JavaScript. Let's just go with it because I know that language already. Or do we want a relational system because I'm not scared of learning something new. So there are other considerations as well. There are like considerations of certain features. For example, MongoDB has a great feature built in, which is geospatial analysis. So if you want to keep records, let's say you're making a mobile app that's the next, Yelp or something, where you're keeping data about restaurants and their locations and reviews and so on, which might sound familiar. You'll store probably geo coordinates of each restaurant, and you might want to have a user walking down the street click a button to see all the restaurants, rated 4 stars and up in their location. That would be a geospatial analysis. You have to compare the user's location on their phone to the locations of all the restaurants in the area and find the ones that are within a certain radius. That kind of geospatial analysis is built into MongoDB and is available in all the other big relational database systems as well, but not kind of included out of the box. You'd have to install extra stuff to get it to work. So the fact that that's already included is, again, a nice feature of MongoDB that makes it attractive to app developers. Anyway, I guess let's digress enough there and go back to the main topic here. So a database server can house many collections. Documents can contain the equivalent of primary and foreign keys, but they're not really used as much in MongoDB. In a relational database, the relational concept is really all about joins, all about joining different data tables together via some common primary key, foreign key, or some other common shared data. You don't do that as much when you're using Mongo. The MongoDB is part of a movement of new databases called the NoSQL movement. And these are newer databases that are shaking off the SQL language and not using it anymore. SQL has been around for since before I was born, I think, and it is archaic looking to most programmers. It doesn't look like a more modern language like you might expect, and so people are trying to adopt more modern languages in their databases, like JavaScript these days. MongoDB uses its own query language based on JavaScript, so it is a JavaScript-based language, but they've added on a couple extra things. Kirthana, go ahead.
Actually, I'm kind of curious about this, but I thought there was some because SQL seems to be very readable, I thought there was some relation to SQL and Python. Or is there not?
No, there's no direct relationship.
All right, got it. Thank you.
It doesn't look like Python. There's no direct relationship. It's not, in my opinion, once you know SQL, it's actually quite readable and easy and actually a nice language to use. But to someone who's never seen anything like that before and just knows some programming language, it might be a bit challenging at the very beginning, but I think then you quickly get over that hump and move forward. But some people just get scared away by that change. So MongoDB uses its own query language, which is basically JavaScript plus a couple extra things. And you already know JavaScript if you're a web developer, so that's attractive. And I've linked to more about the NoSQL trend. I'm not going to get any more into it, but there are other databases that are also trying to take off and do things in a new way. Anthony said, no rush answering this. I'll read it anyway. Will we go over cloud-based databases like Firebase? I don't think so. It would be nice, actually, if we could. The problem, well, there's no real problem. It might just take time, and I'm not sure if we have the time to get into it. But if we have time, towards the end of the semester, if we have like a day extra, which we might, then maybe we can jump into that. Usually people who make apps, again, are writing in JavaScript. We're not requiring anybody in this class to have any concept of JavaScript or even want to learn JavaScript. So I'm not going to require any JavaScript coding. So we would have to use Python to connect to Firebase, which is not, most people are probably using JavaScript to do that, but there will be libraries in Python as well. And I'll see if any of those are available and easy to use. So let's say TBD, we'll figure that out if we can. It's schemaless, so there's no fixed schema. There's no requirement that every document has the same set of records. It's something that is up to the developer, up to the person storing the data, whether to, to use the same set of fields for every document or not. That's at the discretion of the person using the database, not a requirement of the database itself, which is something that is refreshing to some people and scary to other people. It's a kind of a lack of constraints that you sort of have to get used to. So you can put whatever fields you want in your documents. You can, even in a single collection, have documents with different fields in them. And moving on. So another feature of MongoDB is it's cross-platform. You can easily install it on a Windows machine, Linux machine, Unix machine. Mac, of course, is a Unix machine. And so it's cross-platform. You can install it on your own computer while you're sort of using it on, if you're making an application and you're using it on your own machine. That's usually a temporary situation. If you are expecting to make an app and have lots of people simultaneously connect to your database, you would use a dedicated computer to do that at some point. But you can test it out easily enough on your own machine. Drivers, what they call drivers, are available to allow most popular programming languages to connect to a MongoDB database and issue commands on it. It's built-in ability to be sharded, which means that you can have one database split across several different computers or thousands of computers. So that allows you to scale up very easily. You can have one computer until you realize you have too many people using the database and you need more than one, but you can have the same database program spread out and running in parallel across many different machines. That's something you can do with other databases as well, but it's not usually built in, whereas it is built in here. All right, it's fast for large data sets, tends to be. It has a variety of indexes, which is a way of pre-sorting and pre-organizing the data, which makes retrieval of data faster. For example, in SQLite or any relational database, your primary key field is automatically indexed. So records are automatically stored in an ordered way based on the primary key. And you can add additional indexes to a relational database in addition to that, but that one comes built in. And so MongoDB has a similar sort of a setup. They pre-sort by a variety of metrics the data, which makes retrieval faster. When you're looking for something, you don't have to scan through every single document before you find it. It already has kind of pre-sorted and you can scan through subsets. Supports many aggregate functions like SQL does, averages, mins, maxes, and so on. All right, has geospatial search, as I mentioned. You can search for documents near a certain location. That's built in. And you give it a certain radius, it'll return to you records that have a geospatial coordinate in the range that the radius defines. I think that's pretty much it for the features of MongoDB. It's used widely. GitHub, Etsy, Google, eBay, Expedia, they all claim to be using MongoDB. Now, I will guarantee you that they're all also using plenty of other database systems as well. A company doesn't just use one database, right? They've got dozens, hundreds of different databases for different purposes, and I'm sure they're using SQL, and I'm sure they're using SQLite and other SQL databases as well, but they are claiming to be using MongoDB, at least for something. We don't know exactly what. Questions on anything about the features of MongoDB before we go into setting it up and running some commands on it? All right, let's get to setup. So you're going to have to do a little bit more setup to get MongoDB working than you would have had to do for SQLite, because SQLite is light and MongoDB is not light. So SQLite doesn't require much setup, actually. It doesn't really require any setup, whereas MongoDB does. So there are a couple easy ways we've got to try it out. There is a downloadable form. You can just download MongoDB and make your own computer into a MongoDB server. That's fine if you're just testing it out yourself. You don't want other people connecting to your computer to get data. So this is just for a one user kind of an installation. And that's good for testing out. And then when you actually make it a program or an application that you want other people to use, you'd probably put that up on a web server somewhere so other people can access it publicly. You don't want public people connecting to your computer to access your data. But this is something you can install on your own machine freely and easily. I don't recommend you do that in this class, but you can do that. MongoDB Atlas is a cloud-hosted database, MongoDB database server. What does cloud hosted mean? It means on the internet. So you've got a server on the internet that you can connect to, and so you can just tell your computer to connect to that MongoDB on that other computer, and you can start to use it. We also, in our department, have our own MongoDB server, and that's what we'll be running through to some degree today. And that's what I would recommend that you use. We have a special computer dedicated to serving as a database for MongoDB. It's called class-mongodb.sims.nyu.edu, and it runs at specifically port number 27017. So any computer connected to the internet can have different programs respond to different ports, which are like doors into the computer, virtual doors. And so this is running on port 27017, which I believe is the standard port for MongoDB programs. So that computer listens for incoming connections at that particular doorway. And when it receives a connection there, it knows that it's a MongoDB program that is trying to get access to some data. So you're all going to have access to this. This is actually a link to our department's page about how to set up this account that you will have. I've got my own notes here as well in this slide. So that's what we'll use. So you will need to create an account with that MongoDB server. You've got to go to our class MongoDB manager, which let me just pop that open for a second. It's just a web page that has instructions for how to log in and create an account. You will have to log in with your i6 account. You all should have received an email that says you have an account set up on the computer called i6.nyu or .sims, .sims.nyu.edu. This is all written here, but just the brief story is you need an i6 computer account, which everyone in this class has or should have. And if you don't, then we'll figure that out. But everyone automatically gets that when they register. So plug in your i6 account username here. That should be the same as your net ID. So mine's AB1258, for example. Plug in your i6 password. That is, again, i6 password, not some other password at NYU, which you should have received in an email. And plug that in there. And initialize database. I've already done it, so I won't do it for you. But that will create the account, confirm the account, and show you your password. So, so your login for the database will be the same as your i6 login, but the password will be different. And when you get to that next screen, when you click Initialize Database, that's where they disclose your password to you. So just make sure you take it down so you can log in. All right, so you log in with your i6 credentials on that page, and then you get a password for the database server. So you're going to need 4 things to connect to this database. The database server or host name. That is this class MongoDB Sims edu thing, port 27017. Your database name. Each of you are going to have your own database on this server. So a server can hold many databases. A database can hold many collections. Collections can hold many documents. You're going to have your own database name, which is going to be the same as your net ID. So that's easy enough. So you're then going to have a username, which is the same as your net ID. And then you're going to have a password, which is specifically for this database system that was shown to you on that page on the manager site. So all this other stuff is predictable. The password is something you definitely need to be writing down and keeping somewhere safe. You'll probably forget this as well, so write all this stuff down somewhere so you don't keep losing it and having to look for it. All right, so you have your credentials. By filling out that form, clicking Submit, you've got everything you need to connect to the MongoDB. Now, what do we do from there? You're going to need a client. This is a program that's going to run on your computer or some computer you're using to connect to that database server. You can't just connect directly. You need a special program to connect, make connections in the MongoDB right protocol to get data out of that database from that other computer. So there are a couple different clients, programs that will run on your computer or some computer you're using to connect to the database and get the data. MongoDB has their official shell. You can download it, install it on your own computer, and there you go, you've got the program. You can use a programming language like Python that has drivers, these add-ons that will allow it to connect to MongoDB servers. And you can also use SSH, which is a protocol for remotely logging into another computer to log into our department's i6 computer, i6 sims.nyu.edu, And in there, we already have the shell, the client shell installed. So that's what I'm going to run through here. You all have accounts on this i6 computer, which we just call i6. And you can connect to it using this program called SSH. And then you're logged in remotely into this other computer, this i6 computer. And from there, you can run the client called Mongo. All right, so Mac users, you already have SSH. Good for you. Windows users, you have to be using Git for Windows, which I think I've already asked you to install long ago. So I think that you Windows users already have this. But if you don't, get Git for Windows, install it. It comes with a part of Git for Windows that it gets installed is called Git Bash. And that is going to have SSH in it. So if you pop that open, which many of you may already have done, you will be able to write the SSH commands. So click that link, download the thing, install it, run Git Bash, and you're now going to be able to write commands that are using SSH. Okay. So here's the command to log into the server. So SSH, and then your net ID, or this is technically speaking your i6 account ID, but that's the same as your net ID. Then and then the server you're trying to connect to, which is i6simsnyu.edu. Let me just show you as an example. Let me quit out of this. All right, so if I do SSH ab1258 at nyu.edu, let me get zoom out of my way, and I hit enter, I will be logged in, hopefully. It's taking some time. It's not usually this slow. Oh, so I shouldn't do, I'm sorry, it should be i6, not just nyu.edu. That's why. i6.sims.nyu, sorry about that, .edu. The other server was just rejecting me, I suppose. Okay, so there we go. I'm logged in. Now, you'll be asked for your password. I'm not, because I've set something up that will avoid that, but you will be asked for your password, and enter in your i6 password that you've received in an email about i6. And that will be the way that you get into the i6 server. 1 second, I have my daughter here who needs a little bit of help. I can't help you. Can you grab from? Go. Thank you very much. All right, sorry about that. So we've got the i6 connection made. We're in i6. You'll, again, be asked for your password. Fill it in. When you type your password, by the way, you'll notice it doesn't show up on the screen when you're logging into i6. That's fine. It's not showing up on purpose. The passwords should not show up on the screen because someone looking over your shoulder would see them. So when you're in this text mode and you're entering in your passwords, it's normal for it not to show up. All right, so you will log in using that command, where that's replaced with your net ID, of course. Enter in your password. Don't worry if it doesn't appear as you type it, and you're into i6. All right, so once you're into i6, you can run the Mongo command. That's the Mongo client that is already installed on i6. So before you do that, you should be running this command. This is going to load up the Mongo client, actually. It has to be kind of loaded up in memory. So just copy that and go back to where you were and paste it in. All right, we've loaded up the module. I'll show you a way to do that automatically in a second, but that's something you manually will want to do at least the first time. And I have details on how to do it automatically, and then you can now connect to MongoDB, the server that we have. So I'm going to copy this command, which I've given you, go to here, paste it in, and this is the connection command for the Mongo client. We're using i6's installed Mongo client to connect to this other computer, class MongoDB, to log in. So you're going to replace the net IDs with your own net ID. So mine is AB1258. And the host name will be the same for everybody, class MongoDB Sims NYU. Your username is also your net ID. And -P means the password will be asked for you as a separate step. So just leave that as it is. Enter in your password. Do I have any idea what my password is? Let me just stop sharing my screen for a second and load up some secret password information I've got on my screen. And we'll get into that. I don't remember these kinds of passwords at all. All right, let me share my screen. All right, I'm going to paste in my password. Again, you won't see it show up. Totally normal. Don't worry. And now I'm into MongoDB. There we go. So I'm connected from my computer. I've SSH'd into i6's computer, that web server computer. From i6, I've used the Mongo client to connect to the Mongo computer. So I'm kind of 2 computers down the road. And now I can prove to myself that I've got JavaScript working. 1 + 1 is 2. There we go. I've just figured out an important fact. I'm connected to MongoDB. Right? This is actually JavaScript code that's being written. And we will here write the commands to access the data, to set up our databases, to play around with CRUD, creating, reading, updating, deleting records, and all that stuff. All right, so that's the flow for initializing your account. Remember, you have to set up your account with our database server. You've got to then log into i6, and then from i6, log into the Mongo server, and that's where we're going to do our work. Again, you could simplify this. You could install MongoDB directly on your own computer. You can download the MongoDB server and run it on your own computer. You can download the MongoDB client and run it on your own computer and do this all on your own computer. Of course, that would be requiring less commands, probably, at least the first couple times. But this is not really a big burden if you get the hang of it. Okay, so let's go back to my slides for a second. Prove to yourself you're logged in with 1 + 1 and so on. If you want to automatically do this command, so you don't have to repeat it every time you log into i6, which is what you would normally have to do, there is a way to automate that, as I mentioned when I discussed that the first time around. So you log into i6, you want to automatically run this command, which loads up the Mongo client, allows you to connect to the Mongo server. The way you do this is by adding a file called .bashrc into your i6 account. The easiest way to do that is from this command line. Let me just disconnect from Mongo, which is Control-C to disconnect. I'm on i6 now. I'm just looking at my i6 prompt here. It shows me my login and my server. In Unix or Linux, you can do Emacs, which is a text editor. And I can say emacs.bashrc. This is a settings file for the command shell, which is called bash. So it's the settings file for my command shell. Now you'll see that I have already in here the line that says to load up that's the same line I asked you to write in your command shell on i6. Here I have it in this file, which means that every time I log in, it's going to automatically run this line, and it's going to run that line as well. You might as well add them both if you're going to be working on Python later. So this will have my server account automatically load up these 2 modules, Mongo and Python. So if I'm going to use these all the time, well, I have to keep typing them again, and this will do it automatically. So open up that file, bashrc. Sorry, it's .bashrc. It's a hidden file. Put these 2 lines of code, or really all you need right now is the MongoDB line, and save. How do you save in Emacs? It's Control-X and then Control-S. That's saved. And then to quit is Control-X and then Control-C. This is a text-only based editor, so there's no clicking buttons, nothing like that. I have that in my notes, how to save and how to quit, so it's written up there in the slide. But that's the way that you would get your .bashrc file there. If you want to prove to yourself that that's what happened, you can use the cat command .bashrc, and it'll just print out on the command line here that what the contents of the file are, and you should see that you've got these 2, or just this line, written in there. We will be running Python code later, so you might as well add this one in there as well. If you are watching this video, module load Python-3.8 will make sure that when you run Python in later classes, it's going to be set up to the right version. Questions about this? All right, so if you're not doing that now, good, at least you're watching, and just make sure you try out all these steps. They're all listed in these slides. I think it's pretty straightforward if you just follow the instructions in the order that they're written, and I don't think you're going to have any problem. If for some reason you can't log into i6, the password is getting rejected for some reason, there is a password reset link I have in my slides to reset your password to a new one. I think that shoots you an email with a new password, so just wait till you get that email. But everybody should have an i6 account set up, so you should be able to log in, assuming you're entering in the right password. Okay, I think that's it for this slide deck. And now I'm going to move to the other slide deck, which is about CRUD. So let's go to that one. So there's the second link here, which is, so I have two links, the setup and the CRUD link. I already have it open. All right, so once you're in MongoDB, what do? Well, CRUD, of course. And of course, CRUD stands for create, read, update, and delete, just like it did in relational databases. All right, so to do CRUD, or to run through the examples that I am showing, I want you guys to try and load this example data file. So I've given you a JSON file. Remember that JSON is more like the native format for Mongo, just like CSV is kind of like the native format for SQL, because the records internally in Mongo are stored in very much the same fashion. So importing JSON is actually easier than importing CSV into MongoDB. So the data here is in JSON format, which of course has some redundancy. Title is repeated all the time, author is repeated all the time, and so on. Remember, MongoDB doesn't require a fixed schema. So it's possible to have different fields for the different records. Now, in practice, you're usually going to have the same fields in a single collection. All the records in a single collection are going to have the same fields. But in theory, you could have different fields. All right, so this is all the same fields for each of these records. So this is about books. We've got the title of a book, the author of a book, the year written of the book, what edition, usually the publisher, and the price. I just made these up. So you've got some book information. Imagine this is a bookshop of some kind that has the classics, and you're going to want to save that into a data file and get it onto your import it into your MongoDB. I've given you a link to a file. This is just the plain text version of that. You can do from your browser file save, and it'll save this as a JSON file. So file save, put it somewhere where you'd like to keep your files, desktop, books.json, good. And now you've got the JSON file. The next thing is you want to get this up onto i6, because remember our workflow is we're connecting to i6, and from i6 we're connecting to MongoDB server. Right, so to import this into MongoDB, we first have to actually put it into i6, and from i6, we can then import it into Mongo. We're not doing, at least in my examples, we're not doing direct connections to Mongo's server. To get a file up to a web server like i6 or any server on the internet, you can use a file transfer program, and the one I recommend you use is CyberDuck. So CyberDuck is one of a million different file transfer programs. It happens to be one that works pretty well on both Mac and Windows, and it's open source and free. So why not use it? So it also has a rubber ducky as the icon, which you can see on the corner of my screen. So we've got program CyberDuck. Once you have CyberDuck, you'll pop it open. It'll look something like this, and you won't know what to do. You'll click Open Connection. It'll ask you where you want to connect. So this is a program dedicated to transferring files from one computer to another. So what I'm going to be using it for is connecting to i6, and then taking a file from my computer, this book's JSON file, and moving it up to i6. And then from i6 on the command line, I'm going to go and import this into MongoDB. But this is just about getting it up to i6 the first time. So I'm going to use a connection protocol called SFTP. Our i6 server does not allow regular file transfer protocol. That's unencrypted. Our server requires you to be using an encrypted connection, which is secure file transfer protocol. And so that's what you have to select as your first option here. You're then going to say what server you're connecting to. That's i6 sims.nyu.edu. And they don't allow anonymous people to put files there, so we need to enter in our i6 username and password. Mine is AB1258, and it saves my password because I've done it before, but you'll have to type in your password. If you're on Mac, add it to the keychain. That means you won't have to retype your password every time. Connect, and hopefully you're in. There we go. So these are all the files on my personal i6 web server account. You'll have probably a blank or close to blank set of files, but I've got some stuff I've done before. All right, so then you want to take your file from your computer and drag and drop it onto this computer. So this is like a little window into my i6 account. So I'll go to my Finder on my computer, go to my desktop. I'll find that books.json, And I'm just going to line up my windows next to each other. Let me just close down some stuff I don't need. So I've got my CyberDuck window over here. This one over here. If I can get zoom out of my way, I'll grab it. Oh, never mind. Okay, and I've got my books JSON here. And I'm just going to drag from one of these windows, drop into the main area of the server window. Don't drop into a folder because that'll actually put it into the folder. So drop somewhere where it's not a folder and you'll get it into the right directory. So it's uploading books.json up to my i6 account. And when that's complete, you should see it show up in the i6 account. There it is. So there we go. I'm now in my i6 account and it's there. So I can close down my local computer's files and I can now go back to terminal because we're done with the file transfer. So the next step after you've got the file uploaded is to import it into your database. There's a special program on i6 called Mongo Import that will do this import. So here we go. Go to your, oh, I'll just copy this line, copy that line, go to your terminal again where you're logged into i6 already, or if you're not, log into i6, and paste in that command. Now it may or may not work. It failed. Error connecting to DB server. Well, I didn't actually plug in the right database name, the right database host, the right username. I unfortunately copied it with the line break included. So let me just try and get it without the line break included and do it again. So I can actually go and modify this command a little bit. All right, so the command will require you to enter in your own personal database name, your own personal account name, and so on. So remember your credentials. Your database name is actually your net ID. So that is AB1258 for me. The host name is that host name that I'm not going to remember, but it's something like class-mongodb.sims.nyu.edu. Your username is the same as your net ID, I believe. And your password is your password, which of course I don't remember mine. But I'll look that up in a second. So you're gonna enter in your password right here. And also this is the collection name. This is the name of the collection that you wanna put the records into. Just give it a new name. You don't have to preset up a collection. It's actually gonna be created just by doing the import. And this is the file. So if you're in the same directory where your file is, your data file, then just put the file name. If it's in some different directory, put the full path to that file. Questions about this so far before I plug in my password? I'm going to grab my password. Any questions so far? Anything? All right. All right, so that's the password. I'm going to hit enter. And hopefully everything is plugged in correctly, I think. All right, there we go. Imported 13 documents. That's about right. So that should be the correct number of documents. Questions so far? All right, so so the process here is I'm on i6. I've used a separate program, file transfer, in this case, the CyberDuck file transfer program, to get my books file up into my main folder of my i6 account. That's just an easy way to transfer files. You can transfer files from the command line, but it's just more complicated. And then I've run the Mongo import command, which connects to that database at that other computer, class-MongoDB. I give it my credentials, my database name, the collection I want to put the records into, my username on that server, my password on that server. Please don't steal my password. And the file that I want to pull data from. And there you go. You've got your connection made and your data imported. Now we can actually reconnect to MongoDB. I'm hitting the up arrow to go through commands I've run in the past. So there we go. That's the connection command to now log in to that server with the Mongo client. Paste in my Mongo password. And I'm in MongoDB again on the client. So now I can do a DB that will show me I'm in the AB1258 database. You're only going to have access to that one database, so you're already automatically in the right database. And I can now say db.books, because that's the collection, .find. This is JavaScript code. I'm running a function called find on the books collection in the currently active database. And there you go. I've got all the data of all my books. Mark Twain, Virginia Woolf, J.K. Rowling, all the main authors of the day are published here. Not really of this day. These are mostly old authors. And so that's proving to me that I've got the data imported. All right, so back to my slides. So now I can start to do CRUD. As I mentioned in passing, you don't need to explicitly create a collection. So this is unlike SQL. In SQL, you had to make a table, right? You have to set all the schema, the data types for each field, which one is the primary key. None of that is necessary here. Tables don't exist, but collections are automatically created as soon as you put a document into a collection. It makes that collection. There are really no settings to a collection except the name. If you want to insert a new document into a collection, this is a kind of a command you can run, db.yourcollection_name.insert, and then supply it a JavaScript object with the fields and the values that you want to plug in that record. So let me just copy that and run it just to show you. I can paste in that data, and I've now got a new record inserted, which we call a document, of course, not a record or a row. All right, so there's the insert function, and that's how you insert a new document. Just remember, it's being called on the collection. So if you're in a different collection, this would be a different name. And then DB always is a built-in variable that refers to the currently active database, which in our case, we only have one. All right, so that is inserting a collection. I'm sorry, inserting a document into a collection. If you wanted to read your documents that are already in the collection, you can use, as we saw briefly, we can use the find function. So I showed you just briefly that you can do db.books.find and get back all the stuff you want. There are two arguments you can optionally put into the find function call. The first are the criteria. That's going to be a JavaScript object that represent the criteria that must be matched in order for a book to be returned. I mean, in order for a document from the collection to be in your result set. And then the projection. So the criteria are like using SQL's where clause, where you're limiting which records will be returned to you. So the criteria serve the same purpose. And the projection is like the list of field names that you want. So for example, I could change my query I did, not find everything, but I can put criteria as a JavaScript object. I can say where the author is William Gibson, for example. I just entered William Gibson. And I can say comma and then my projection. Well, let me just do William Gibson. I'll just do that as criteria with no projection. And we'll just see that for a second. So I get back just the records that match, just the documents that match. In this case, just that one that I just entered, which has the author, William Gibson. So you put the field name you want to be matching and the value you want to match against, and it will return any records that match that setup. If I wanted to just get the title of the book, I could put a second argument. That's the projection, as they call it, the field list, basically. Oops. Let's do it again. The projection as a second argument. Again, a JavaScript object. And I can indicate which fields I want returned to me. So title : 1 will mean return that to me. That should not return the other fields, except ID. Now, we'll talk about that in a second. But I did just get the title and not the edition, not the year written, not the other stuff that might be in this data set. It does automatically include ID by default. Notice in my data file, I don't know if you were paying attention, but in my data file, let me zoom out of my way. I don't have any ID field. So in that data that I imported, there was no ID. There was no table setup where I said to make an ID field as a primary key. So this ID that you're seeing is inserted automatically by MongoDB. So every single document that you put into a MongoDB collection will get a unique ID automatically assigned to it. You don't have to add that in, which is great because everybody puts that in manually. Why not just have it be a feature of the database? All right, so I see there's another question, Gautam. Under which document will the collection be created in? Whichever document you say to create it in. When I ran that insert command, if I can find it, it was on the books collection. See how it says db.books.insert. If I had a different collection name there, then it would be a different collection it got inserted into.
That's not exactly my question.
Oh,
I was trying to ask, like, when you have Mongo locally, you can click like use and then select like I don't know if it's like a document or like the collection of the collections.
that's the database. When you use the
Yeah.
use keyword, you're picking a database.
Okay, so in this case, does it just default to like your net ID?
Yeah, the way that our server is set up is that every user has just one database, which is their net ID. It's the name of the database. And
Okay.
when we logged into our server, let me see wherever that was. Sorry, when we did the import, wherever that was, we actually specified which database to import it into, and we called it our net ID database because there's only one.
Okay.
Sure. Okay, so if we don't want that ID field returned in our result set for whatever reason, there is a way to, of course, turn it off. And you do have to explicitly turn that one off. So I can say underscore ID is what it's called, 0. You have to explicitly say that one's turned off. The others, if you turn something on, all the others except ID will be automatically turned off. So this is the exception is the ID. You have to explicitly turn that off. And then I get back just the title. All right, so this is like the where clause, right? This is the first argument is like the where clause. Give me all the records where the author is William Gibson. I only have one. And don't give me all the fields, but give me just the title field. Make sense so far? Okay, let's carry forth. So we've already seen how to retrieve all documents. You just don't supply any arguments to the find function. We can find by an author or by any other field by just putting the field name and colon and the value that we're trying to match. So that would find all the books by Leo Tolstoy. One criterion with an operator. So there are operators in MongoDB. Let me just pull this code in and show you. And they might look a little odd to you. A lot of things about MongoDB will start to look a little odd to you. But this is going to find, again, I'm going in the books collection and finding, and these are the criteria that I'm supplying. So that means all records have to match this set of rules in order to be included in my result set. The price has to be, but I actually don't want to include just one price. I want to include anything under $25. So the way you do that in this odd JavaScript syntax is you put another set of curly brackets and you put $GT for greater than. I'm sorry, this is above $25. I think I said below. So anything above $25 will be greater than $25. And that will be what is included in my result set. So I've got only 2 books, it looks like, greater than $25. That's Virginia Woolf's A Room of One's Own and Tolkien's Lord of the Rings. So there you have it. One is $29. That's the price of that one. And the price of Lord of the Rings is $27.45. Good deal. So again, that's how you do a kind of greater than operation. You have to have this extra set of curly braces and supply it that way. Now, the reason why that is if you were to do it differently, let me just show you, like it would be nice if you could just do something like greater than $25 or something easy like that. That would be wonderful if you could write that syntax. And I'm sure the people who made MongoDB would love for that to be possible. Unfortunately, this is a operator in programming languages like Python, but also like JavaScript. This is an operator that exists in JavaScript. And that's how you do comparisons in JavaScript, just like you do in Python. And the problem is that this will be evaluated, whether this thing is greater than that thing, will be evaluated by the JavaScript interpreter that we're running here before it even sends it to the database. That's the way these kinds of expressions work. They're immediately evaluated to some result. And that will be before this argument is being passed into the database with this find function. So before even calling that function, it'll first figure out, is this greater than 25 or not? That's not what you want. You want to send the message to the database to do that operation, not do the operation first and send the result to the database. So actually, I think they caught themselves up in a little bit of a bind by using JavaScript where they had to do this additional weird stuff to make this not actually get sent to the database as a result, but have the actual command to do a greater than operation sent to the database for it to perform. So they had to use a different kind of syntax for this, not the built-in JavaScript greater than syntax. So you're going to find a lot of weirdness in JavaScript as a result of that kind of problem. Yes, it's a JavaScript-based environment, but unfortunately that means that your commands are interpreted before they're sent to the database. And so you have to take care of that with this weird escaping kind of syntax. Anyway, so that's just how you have to do it. And less than, of course, is LT. Greater than or equals is GTE. Less than equals is LTE. So things work as you might expect them to, but getting used to these curly braces can take some practice. Here's another one with two criteria. So let's just take a look at that for a second. Here I'm going to find books that match this criteria, these criteria. And I'm also supplying this projection, just reminding you to get rid of the ID. That's how you do it. All right, so what am I looking for? I'm looking for books where the price is greater than or equal to 10 and less than or equal to 20. So books in the range of $10 to $20 inclusive. That's what we're going to get here. But notice that there's an implicit and, that I'm looking for books that are both greater than or equal to this and less than or equal to that. You don't have to write the keyword and. There is a way you could write the keyword and, but it's the default operation. If you're putting some criteria next to each other like this, it's assumed that you mean and logic, not or logic, not books that are either greater than 10 or less than 20. That would be different. So it is implied that it is an and logic. Let's run that one, see what books we've got. All right, Northanger Abbey, Anna Karenina, War and Peace, pattern recognition are all in the range that we're looking for. Okay, let's carry on. There are, just to remind you, some other operators. So GT, GTE, LT, LTE for less than. There's also not equals to. If you just want to check if something's not equal to something else, there's the NE operator. And you can find examples of these. You know, I'm just giving you the list of the operations. You can look up examples. I have some in my own notes, of course. There are other logic operators. So there's the AND operator. If you did want to explicitly say AND, you can use the AND operator. There's the explicit OR operator, which would have to be used. There is no implicit OR. There is that implicit AND we saw. And there's in and not in, where you check a value against an array of values. I've got a link to a document I wrote up which has some examples of these. I'll put these into the slides probably after class, but right now they're not in the slides. I do have examples of using some more examples of using these operators. If you want to use the EQ to find equality, you could do dbbooks.find, and you could specify your criteria that you want to match. And you can say year written, and then in another JavaScript object, EQ equals 1985. So the EQ operator checks the value of any record, any document for this field. And if it is matching exactly 1985, that document will be returned in your results set. We could have written this year written : 1985. We wouldn't need all this curly bracket stuff in the EQ operator. So the default operation is an EQ operation, and you can just replace this whole thing with just 1985. But if you wanted to be explicit about it, this is the way you would do it. So I'm noting that here. This is the same query. You're doing the same thing. This is, of course, easier. The not equals query, you could look for books that match this criterion where the year written is not equal to 1985. In this case, you do need the extra curly braces because that's not the default operator. Questions? Here's another example of an AND logic combining two different operations, two different criteria. So again, we're doing the find function, and we're going to match based on these criteria. And the criteria have an AND, explicitly an AND logic. So it's going to be an array of criteria ANDed together. And the array is going to have the addition must be penguin. That's the first array element. And we're using the AND operator on that array. So everything in that array must be AND logic together. So the addition must be penguin and the year written must be less than 1985. All right, then we've got OR logic. It's actually very much the same as AND logic. So you use the keyword AND for AND. You can have OR for OR and give it an array of propositions you want to OR together. So the price is greater than or equal to 15, or the year written is greater than or equal to 1900. So this will get me either where the price is greater than or equal to $15 or the year written is 1900 or greater. All right, I see some chat messages. Let me pop them open. Catherine, you asked, the white space doesn't matter, right? Right, that's correct. Does not matter in JavaScript. Most languages it does not matter, except for Python. All right, there's the in operator as well. So we can find books where a value is in some array of values, is one of the values in some array of values. So for example, we're going to find books where the year written is in this array of values. In 1865, we only have two values, or 1925. So let me just run that one just to show you. Plug it in, hit enter, and here we go. So the year written is 1925, that matches. And the year written here is 1865, which also matches, and again, 1865. So again, we've found all the books where it's one of those years. Let's look for 86 or something. Nothing. So just the same results. I don't have any 1986 books. Okay, so there we go. We've got the in operator searching for a value that's one of the values in the given array. Not in works the same way. Give me all the books where the year written is not one of the values in this array. Let's see if there are any. We don't have that many books in our collection. Okay, we've got plenty. Anna Karenina, Tom Sawyer, Room of One's Own are not in these years. Okay, so that's the read stuff. So you're going to have to master some operators like that in order to get the results that you want. These operators, again, the $ and the curly braces can throw you off. Practice them, try them out, get some queries going that are, you dream them up and see if you can get them to work and see if it makes sense to you. It'll start to make sense to you. But at first, it's a bit disturbing with all the curly braces. We saw how to insert a new document, so let me just go back to my slide deck because we already looked at that. There is another interesting function called count. This can just tell you how many records you have. So if you do a find on a certain criterion, in this case, the addition penguin, you can count up how many records match that. So let me just show you an example. It'll just spit out the number. Expected expression, there's obviously an error in my syntax error. Expected expression got dot. What is the problem here? Oh, I think I broke it up on multiple lines, which threw it off. Let's just do find. I'll find all, then count, just to show you. 14. So we've got 14 records. I imported 13. I inserted manually another 1, so that makes sense. All right, finishing up our CRUD here. So that's creating, reading, now updating. To update, you give 3 arguments. The first is the match you want to make, the criteria to find the records that you want to update. So we're going to be updating all books where the year written is less than 2000. Let's say we're doing a sale. Old books are getting discounted, right? So we're going to get all the records where the year written is less than 2000. That's the first argument, is a criterion or criteria. Second argument, the changes you want to make. You can use the set keyword, the set operator, to change the value of a field. So set, and we'll supply the field we want to change and the new value we want to give it. And the third argument is whether or not to apply this to all rows or just the first one. So multi-true means make this change to all records, all documents that we find where the year written is less than 2000. If you made that false, it'll just do the first. All right, questions? Last but not least, delete. There's the remove function. So go into your collection and remove and give the criteria that you want to match for any document to be removed. The author must be this value, the title must be that. And of course, you can use your less than and greater than and equals to and not equals to and in and not in operators if you wanted to do criteria like that. But just the remove function with the same kind of criteria that you used in your read queries. And that's it. Now you know MongoDB. You're ready to get to work. Of course, there's more. There's more practice you'd have to do, but this is the basics. Just like we saw with SQL, the basics of using a SQL-based database are to master your CRUD queries: create, read, update, delete. Yes, you have joins in SQL, and yes, you can have join-like things in Mongo, but they're typically not as common. Why is that? Because Mongo suggests or recommends that you store all the data in one document that you might need. So rather than having the need to join two documents from two different collections, their recommended workflow is to store everything you need in one single document. The reason being it makes your database faster, and that's what they're really designed to do, is to have fast lookups. So yes, they provide some foreign key type lookups, but no, it's not the norm for all records anyway. It's not the norm to do it. Whereas with relational systems, it is entirely the normal way that you do database retrievals is to do joins from multiple tables. Any questions, comments, anything at all? Abdullah, you say, could we apply the and or operators successively, as in have the and or apply on an array containing elements which in turn are applications of and or? Yes, definitely. You can nest these things. Yep. I didn't want to show that. I didn't want to scare you too much, but yeah, these things can get, you can have more operators piled on top of other operators for sure. Other questions? All right, I'll turn off my recording and I'll hang out for another minute, and I'll see you all next time.
Thank you for